Hey, what is up guys, and welcome back. So today we're going to be taking a look at a new flight controller from FrSky. Now this is a pretty interesting one. This is an F7 flight controller, dual gyros, 8-volt regulator, and a bunch of other features. So let's get started here. So as you can tell on the top here, we have a soft mounted ICM 2068 gyro. Below it, you have the MPU 6000 gyro. So you can choose between these two as your quad desires. If you have a really oscillating quad, if it has too much vibrations, you can drop down to MPU 6000. Now they're stating that it can run full 32K. So I don't know if that's true, but we're gonna have to test it soon. And if we take a look at the back here, we have a built-in receiver, I think talking through SPI, and it is the RXSR, and it is already connected and set up in Betaflight to run F port right out of the box. So you have that set up. That's one less thing for you to deal with. And if you wanted to bind this receiver, what you do is there's a little opening right here, and you would just click it right there, and it's really tactile, and you could actually feel that you're pressing something. So that's a really nice thing to have. So they're using really good buttons there. It's always a big plus. And here's the boot button right there if you ever needed it. Now let's talk about the layout and how we would actually install this into our quadcopter. So the layout of this flight controller is quite remarkable here. If we take a look at the flight controller manual / schematic here, we can actually get a better idea of what's really going on here. Now, if you didn't want to use the ICM gyro, you can easily remove that. And if you didn't want to use this receiver, you could easily pop that off and you're good to go. The flight controller will still function just perfect. Now, as you can tell here, they've provided a pinout or a 4-in-1 socket, they're calling it. So it's a connector if you want to connect some sort of 4-in-1 ESC, and this is the order it's working at. So you got VBAT, RX5, would be the telemetry, ground, NC means not connected, S1, 2, 3, 4, which is motors 1 through 4. And up here, this is kind of interesting actually. So let's get a closer look here. So we have this pad up here, which is V in, which means video in. So this is where you put the video wire coming in from your camera, as you can tell right there. And this is just a big ground. And here's V out. So this would go to your VTX. The video line would go piped out to your VTX. So you go in here, go through the OSD and pipe out through the VTX. Now it's very important to ground your VTX and camera on the same pad here, because they do have an LC filter inside to reduce noise if your ESCs are generating a lot of noise. And if we take a look at the other pad right below it here, this is an 8-volt regulator. Now the 8-volt regulator, don't expect it to power on when you put in a 5-volt input here. You have to power this off directly from a battery, and this thing takes from a 3 to 6S LiPo raw battery input, and we're going to take a look at where we actually set those up in a bit. However, we're not done here yet. So if we take a look at the pad right below the video out, it's Cam C, which means camera control. So you can control your camera's OSD through this, which is also a really nice feature. And if we take a look at one pad lower, we have the TX1 for smart audio to control your VTX if you wanted to do that. So this side is really well thought out. This is the second time I've seen it on their second flight controller that they really took their time, I think, designing and just thinking about this. I think that's the MPU 6000 gyro right there. It's too small for me to see. Let's see, what else do we have? Like I mentioned, we have our boot button, we have the gyro connector here. Try not to play with these and remove them, because the plastic, if you strip it, you're screwed. This is how they come, all of them, especially from Airball. I've had that happen to me before, so don't really play with it. So if you want to use S port, obviously this is an F7 flight controller, so you don't need to worry about which exact port you have to use, because it does have an inbuilt inverter in the F7 microcontroller unit. So there isn't, a specific pad for S bus and a specific pad for S port, because it's inverted. You can place it basically anywhere. But they have set up TX1 and RX1 for S bus and S port here, just in the manual, but you can use them for anything also. So you can even set up iBus here if you wanted to. Like for example, on RX1 you could set up iBus. So that's really nice here. And then we just go straight down. We have TX2, TX3, and then TX4 and TX5, and then we have SCL and SDA, which is the I2C, which is the IC squared protocol. So if you wanted to do some kind of GPS or something, but most GPSs anyways go into one of the UARTs here. We also have a separate pad for RSSI, which is this one right here, which would be that one. And we also have an external ADC. I think this is an analog digital converter, possibly for current sensing, would be right here. And we have a buzzer negative. So the buzzer positive, you would put it on a 5-volt somewhere. You could put it right here. That's a 5-volt. So if you want to bring a wire here from 5-volt positive wire to your buzzer, and then here's the negative, because this is what will make the buzzer go off once the negative is initialized. That'll make the buzzer beep here. And the pin right here is for LED. This is the LED control. So if you wanted to basically control it, this would be the signal to control the color of the LED, the RGB LEDs right here. And here we have a big pad, as you can tell, 5-volt DC. It's because they can't fit so many 5 volts, so they just give you one big one here. It might be a little pain to start soldering this because it's so close, especially if you're new and you don't know how to solder. Just be extra careful. This is where the 5-volt you would set up. You could put more than one wire. That's why they gave you such a big pad here. 5-volt USB. This will most likely only be powered once the USB is connected. If not, then it won't be, but I could be wrong. But just take that into consideration when building it. So if you put up your buzzer here and for some reason it's not working, it's because the 5-volt from the USB. Here they give us an extra 3.3 volt regulator if you needed something to power off the 3.3 volt regulator. Now I know the 3.3 volt regulator is rated up to 200 milliamps maximum, and the 8 volt and the 5 volt regulator on board are rated up to 1 amp. All right, so this is pretty interesting. I think we're going to see that this supports iNav possibly, because as you can tell right here, we have the 5-volt BECS right there. So we have the, for example, you want to connect ESC1 or the signal from the ESC1. You would connect it here, and the ground is here if you wanted to connect the ground, which I highly recommend you always connect the ground. And here we have a BEC, which means this is a 5-volt, 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 5-volt. Just the first 4 are 5 volts. 1, 2, 3, 4. These are all 5-volt pads. And the reason for that is if you wanted to add servos, you can power them up. But other than that, you really don't want to touch these unless you want to power up something from a 5-volt regulator. Just keep that in mind here. So the ground is here, the signal is here, and it goes up to 6. And obviously you could remap other things to work, but out of the box, it comes up to 6. And these 2 pads here are for ESC telemetry if you wanted to use them. You can connect them like 2 wires. So 2 ESC telemetry wires would go into this one and another 2 would go into this one because it is RX5. So then ESC telemetry would be on RX5 here. And again, these are the only ones that have the 5-volt output from. And here we have another separate RX5 connection for ESC telemetry. And here we have a current sensor. So if you wanted to stick your current sensor, you can do that here. You also can do the same thing here. As you can tell, we have the RX5 and current. So this would be your current meter from a PDB or an ESC, and VBAT. This is where you would put your power to the flight controller here. However, where's the ground? I don't understand why they do it like that. It's kind of weird. We'll see it in a bit right now, but that's kind of strange for me though. So this is the VBAT to power up the flight controller here, because you want to power this up through battery voltage, so the 8-volt regulator on board could actually power up your VTX as well as the camera. And also make sure your camera is going to be able to take 8 volts here. That's very important. Most of them do, but maybe you had some, I don't know, some really cheap one that just takes 5 volts or 12 volts, then that thing won't power up. It'll either burn or won't power up. So yeah, take that in consideration. But most of the ones we're getting now, they go up to like 26 volts, I think. So since we don't have another ground pad to actually give the flight controller from the battery voltage, what you do is you put your battery positive here, and then you would go to ground. You can just ground it here, or you can ground it here. Put the ground to go into one of these. So this would be the battery voltage positive and battery voltage negative, or ground here, or you could set it up here. Now I can see this being just slightly a pain in the butt to actually set up, especially with all the 5 volts right here. But again, you're not going to have to put anything that needs 5 volts really, maybe just a GPS or something. But other than that, I can't think of anything that I might need to power off 5 volts other than LEDs, GPS, because we have everything being powered from right there. And I'd highly recommend you put the positive of your VTX and your camera together and then solder them to this, and as well as the ground. Make sure it goes here for the camera and VTX together. Put them together and then set them up right here, because there's an LC filter. This has probably an isolated circuit going on to keep the overall video image absolutely clean for you. Now they're stating they're using quite a lot of capacitors here, but I'm not seeing that much. The filtration maybe under this probably has some. Overall, it's a really interesting flight control, and it's really nice that everything is just built in. Don't forget dual gyros F7. This will be built after the all-in-one version, because I'm more excited about the all-in-one version because I just love all-in-one flight controllers. But this has its own uses. If it's going to be set up for, if I could set this up on iNav, I definitely will build it in one of my quadcopters that are upcoming, and just to try it out. I've never tried an ICM gyro on a fixed wing or anything, so that would be pretty interesting also. But again, we'll do it on a quadcopter also before anything, because I know that's what you guys want to see. The documentation here is really good. I haven't seen anything this good actually. They go through everything, every single thing you need to know about this. So yeah, that's really nice in that perspective. And well, that's it guys. I really hope you guys enjoyed the video. This is the FrSky F7, and I'll have it linked down below. It looks like a nice little beast, and we'll see it flying very soon on the channel. And I really hope you guys enjoyed it, and I'll see you in the next one. Peace out.